Hi, I'm Ryan Holger with TEC Tube. Today we're going to be installing a GPS FC48AC. This is a bipolar ionizer from Global Plasma Solutions. This one goes up to 4800 CFM, which is 12 tons. We'll show you where to mount it and how to wire it. Let's get started. So on this small air handler here, we have a traditional belt-driven fan. So let's just talk about where we might mount it on this style fan. We have these two needles on here. Airflow needs to be going across the same direction that I am showing right here. I don't want airflow to go this way, because what I'm going to do is use one needle to charge some of the stuff positive and one needle to charge some of the stuff negative, because I want the opposites to happen. I want things to bang into each other and collide and collect with other stuff in the space. So I need positives and negatives. So I have to have the airflow going this way, perpendicular to these needles. I don't want it going parallel to the needles, right? So I'm going this way here, across the two needles. And now I have this airflow. If you think about the airflow coming into this blower, it's coming into the eye of this blower. So it's coming this way from the coil, and then it's turning and going in here. So I got a couple mounting options on here. One option choice would be to mount it on the actual blower housing. Now this is a pretty small fan relative to the size of GPS I have in my hand here. So you probably wouldn't do it this way on this one, but on a really large fan, you might do it that way. And you gotta be smart about these wires too. You have to strap them up so they don't get stuck in the belt or anything like that. But that would allow the airflow to come across this way and then get sucked in. The other mounting option, and by the way, these are magnets on here, which makes it pretty easy. You can screw them into stuff, but these magnets are rare earth magnets. They're pretty strong. It's definitely the easy way to go. In this case, I could also put it down on the base here, down on the bottom. I got it on a slight angle here just to give me a better, if I'm envisioning how the air is coming, it's coming and turning that way, right? And that gives me the best opportunity. I could also probably push it a little bit further back here, but I don't want this belt to hit this little propeller either. So I want to keep it a little bit off of that. So airflow coming this way. I could also take this guy and stick him back further here if I have room. In this case, I don't have room, and I have an evaporator coil and then the drain and the fan, because this is a super small unit. So I don't really have the room to stick it upstream of this fan without literally laying it in the drain pan, which I'm not going to do. Right? So probably my best bet for this application is right here. All right, on these style fans, which generically speaking are called vane axial fans, although we call them eco blue, the airflow is going to be coming around into this blue shroud from all different angles on here. And right, obviously we'll have a door here on the front normally. The majority of the airflow is going to be coming from the back, because that's where the evaporator coil is at. Now that makes me think about how I want to mount this guy on the inside. Once again, I have these magnets on here that'll hold it on, but I don't know where the turbulence is going to be occurring and which way the air is going to be swirling. So my suggestion to you is you put it back as far near the evaporator coil as possible. That way we know for sure we have linear, smooth airflow coming out. So I'm going to take this guy, I'm going to put him down here in the back. I'm going to put him on that angled piece of metal. So on the back side of this heat exchanger section, there's an angled piece of metal like that. I'm going to stick him right on that. So it's still part of this blower, shelf, but on the back side. Now I know I have airflow coming off the coil and going right past those two needles on there. If I was to put it, say, over here like this, I'm not exactly sure where the air is swirling in here and where it's turning, but further back by the evaporator coil, I'm pretty safe. With these two needles on here, we have to keep them clean. So instead of manually cleaning them, this particular model has a little helicopter on here, and every day it just rotates and brushes them off. So any debris that builds up on them because the electrostatic charge just gets knocked away. From a wiring standpoint, we have a couple different options. This particular model, if you look at it on here, it says you can do 24 volts or 110 or 240 volts AC. It's a multi-voltage. Every model's not that way, so you gotta pay attention to the one you have. I suggest you work with ones that are 24 volts because it's just easier to work with low voltage whenever possible. There's 5 wires on here. 2 of them we're seldom gonna use. These 2 that are in the maroon color are for an optional building automation alarm, so we're not gonna need those in most applications. That really makes it a 3-wire device, and it's not super complicated. In white here, I have my neutral. In black, I have my 24 volts AC. And then in green, I have my ground. You will notice on this black one, for this particular model, there is an on-off switch. So when you're done installing it, make sure you do leave it in the on position, obviously. The easiest place for me to get that 24 volts is from R and C, right off the thermostat strip input. It's right there, right? So in this case, black, which is my AC, is gonna go to R. White is gonna go to C for common. And then this green ground wire, you just need to tie it to the chassis somewhere. Very similar to how the Ionizer controller is tied into the actual chassis. I'll just throw another screw on here and put that guy on there. Or stick it under the Ionizer one if you happen to have a Ionizer terminal on there. But pretty easy, 3 wires. Hopefully you guys found that useful. Remember, airflow needs to go perpendicular to the needles and pick up 24 volts wherever you like. probably from the transformer or from the RNC on the thermostat input. We did it today on a rooftop, but if you're installing it on an air handler, a fan coil, furnace, water source heat pump, any air moving device, make sure you follow those two things. Where can I get power? How's the airflow going to move across the two needles? After that, it should be pretty much easy. It should take you 10 minutes tops.